Hello everybody and welcome to our new channel. This is kantailive, and as this is our first stream, basically I want to take this opportunity and give a brief introduction of what this is all about. So basically my name, as I said, is already Christoph, and Kantai is the company that I founded, and we try to help people streamline and make their machine learning processes more efficiently. So we are deep into coding, and therefore we would like to use this channel as a means to help other people, working on their software development skills. And since we have this December, there's always this nice Advent of Code. I don't know if you already know this, but Advent of Code is basically a calendar where every day you get a small programming puzzle, and we would like to present you some way how our work together basically on developing a solution for this puzzle every day. So for till Christmas. So let's dive in. So for this we will use Go. So Go is Golang is basically a program language which is more suited for system tasks, I would say. It's for high performance stuff, and since this is something that I wanted to delve deeper into on my own, I'm by far not really good at that. I would like you to join me and try to figure out how we can solve these puzzles within Go. So let's take a look at the problem that we actually want to solve. So Santa's reindeer typically eat regular reindeer food. Okay, but they need a lot of magical energy to deliver presents on Christmas, so that their favorite snack is a special type of star fruit that only grows deep in the jungle. The elves have brought you on the annual expedition to the grove where the fruit grows. To supply enough magical energy, the expedition needs to retrieve a minimum of 50 stars by December 25th. Although the elves assure you that the grove has plenty of fruit, you decide to grab any fruit you see along the way just in case. Collect stars by solving puzzles. 2 puzzles will be made available. Okay. On each day, the second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. Okay. This is just about the Advent of Code. Now to the puzzle. The jungle must be too grown and difficult to navigate in vehicles and access from there. The elves' expedition traditionally goes on foot. As your boat approach land, the elves begin taking inventory of the supplies. One important consideration is food, in particular the number of calories each elf is carrying. Your puzzle input. Okay, so the elves take turns writing down the number of calories contained by their various meals, snacks, rations, etc. that they've brought with them. 1 item per line. Each elf separates their own inventory from the previous elf's inventory by a blank line. Okay, so we have a list, and so this would be then the food of the first elf, the calories for the second, third, and so on and so on. Okay, makes sense. This is represented by 5 elves. 1, 2, 3, 4, 5. Okay. In case the elf gets hungry and need extra snacks, I need to know which elf to ask. They'd like to know how many calories are being carried by the elf carrying the most calories. In the example above, this is 24,000. Okay, find the elf carrying the most calories. How many total calories is that elf carrying? So get your puzzle input. Okay, this is now the file that we need to solve. Okay, so we're gonna save this. Or maybe just copy and paste it. And paste it into our Golang. New file. Input. Okay, so now the question was how to calculate, find the elf carrying the most calories. Okay, good. So for this, basically, we just need to loop across all those lines, read it line by line, and then every time we encounter one blank file, we know we are now at at the next elf. So this means we will have some elves as a type, and one elf. Is this written with elf? I don't know exactly. Struct. So, and these have a list of items. This might not be the most efficient thing that I do now, so, but I'm trying just to explain how I think about the problem. So, and for this we have a set of item or food item, since we know they should be edible. Each item has calories, and this is probably some, let's make it unsigned, since we know we won't have some negative calories. So this would be actually quite good food if we would have something that would allow you eat it and you basically burn calories. I would definitely be up for that. Okay, so we have our elf and we have our food item. Elf is probably, is this written that way? Elf. Maybe this one. Okay, so now let's get to the point. How do we actually try to read the file? So for that we have this package OS where we can open a file. Yeah, and we just open the file, and this was named elf.txt. And then we end up with a new file. Let's call it input file. Okay, now there's something. Ah yeah, okay, this is something that I definitely need to get used to, is this way how Go often returns error, so that you basically return two different results. One is the main result that you're interested in, and one is the error result. In this case, yeah, we will see. If error, do some error checking. If error is not equal nil, then we know we have an error and we can just panic. So otherwise, we have our file. So this is now something where we try to read this now line by line. I don't know exactly if this is something that is supported. We will see. Input file dot read line. Do we have something like read line? I honestly don't know. So, okay. Let's ask our all-knowingly Google. read line. Reading a file line by line. So, how does this work? Oh, confirm choices. A scanner. Do we actually need to use a scanner for that? Yeah, makes sense, since for determining if we have a line, we need some kind of buffer. Okay, then just do this. We copy this block. Nice hint. We needed to close the file, definitely. Defer input file dot close. So now we have our buff.io. We scan about this. Line is scanner text. So, and what do we do with the line? So, at the moment, yeah, I think first that would be just printing it out. Print line. So, and then let's run it and see what happens. Okay, as we can see, basically it's printing out all the individual lines that we have in our file, all those 2300. Okay, doesn't look too bad. It didn't crash. Nice. Okay, so, but now, okay, we know we want to get the list of all the elves, right? And then basically find out which is how much calories the elf is actually carrying. So for this, we would need to create a elf every time basically we find a new blank line. So for this, we say if line equals blank, yeah, then we just print out some message and say, hey, we created a new elf. Found a new elf. Okay, run through it. And there are a couple of elves that we actually found. I don't know exactly how many. Do we get a number of columns here? No, let's just add a counter. Or just add some new elf and then basically use the counter. So for this we need a new list of elves. So we have our elves and say you are a slice of elf. Make. And we don't need to add set some defaults. Why does it not missing len? Okay, then just 10. To make the, yeah, and elf, we don't use elves. So therefore, then if we discover a new one, we say, okay, elf dot append and create a new elf. And we always have to assign it, since this doesn't not there, so because it's already a variable. So just continue, and yeah, okay, we didn't change what we actually wanted to change. And then we say here we want to print out the number. And from elves. It's 275 elves. Wasn't it WD? Okay, this is something that print line. Okay, this is not a format. Okay, print. Printf, not print line. Okay, printf, and then with a new line at the end. this is more like what we like to know. Okay, so we know our group of elves is have 275 elves. This is not too bad, but this is not actually the information that we are looking for. And I think we might have forgotten one, because if we look at the file basically, then it starts already with a number. So this means that the first elf doesn't start with a blank. So therefore we wouldn't count it, because there is no new line with a blank. Which means we need to initialize or add another elf directly before we run over the file. So therefore we just append an elf directly at the beginning. And now we should have 276. Okay, looks fine so far. So, but now we come to the other case. So, because not all of those lines are actually empty, most of them actually contain numbers. So, what to do with the numbers? For every number, basically, we need to add to the current elf. We need to add some food item. So, therefore, if it's not blank, so else, we pass basically the calorie numbers, calories from the line. So the line is just containing the number as a string representation, but we need, since we want to sum it up, and we need the number value of it. So, and this is something that we can do with string-conf, I think, a to y, which is basically the function which takes in a string and returns the int value. Okay, and again, it should return an error. So, in case of error, we always need to handle that. If we get an error, this could be, for example, if we run into a line which contained text and not a number. So we just print the error and then end again. Print errorf, no, errorf creates an error, format, panic, you just panic. Okay, so, and now we have the number of calories, and for the number of calories we can add a new food item to the last elf, or to the elf that we added last. So, for this we have elves dot. There should be some way of basically getting the last one. I'm not sure. So this would be elves, and then len from elves -1. This should be the last elf, and then we can items and then add there some items equals. Okay, this doesn't look really nice at the moment, I have to admit. Append food item calories. Okay, let's run over it. Cannot use calories as type of uint. Ah, okay, yeah, because we actually used here some. This is automatically in signed value, but since we defined that calories should always be positive, we need to cast this. Okay, so this seems to work. Let's check what happens if we now add some new elf or some invalid elf calorie number. This is some text. Then we should basically expect our program to crash. Ah, okay, invalid syntax, pathing, this is some text, so everything works as expected. Nice. Good. Continue. So, what do we have here? We basically yeah, okay. Now the point is we have the calories passed. We should maybe print them. So what we do is every time we encounter a new... No, the problem is that basically we need to sum them up, right? So we need to go through it and figure out how much calories the whole or all the food items actually have within an elf. So for this we can try to extend or create a new function within the elf type where we say, okay, our elf elf total calories, and total calories returns an unsigned int. So, and within this basically we just sum these up. So we have our total calories yeah, okay, this is a variable. So then we run over all the individual food items that we have for item. No, and we don't need the index. Item range items. So this way, and then we just total calories plus equals item dot calories, and then we just return the total calories that we calculated. So with this basically we can just print out in the end. So when we are done with scanning over the file, basically we can just run over our list of elves and then print out the calories that each individual elf does transport. So for index no. In range elves from a print out imports calories. Index and elf dot total calories, because we just call it there. So let's run. Okay, and there we have our elves with the number. Everyone has an index. As we see, the first one has the number 0, since in Go these are all. Okay, this doesn't look right. So something is fishy here, right? Because why should the first elves have 0 calories? This should not be the case. There is something growing on. Yeah. Sure, maybe this is something that is off. So we have the number of elves. Okay, let's do it without actually... Oh. Okay, now we should have all elves with 0 calories, which makes sense, because we don't have anything. So now the question is, why does the first elves appear without any calories? Yeah, because this doesn't look right. So for this, we can just debug into our program. So we just say debug, and now we can go step by step through the whole program. So we have our input file, we initialized it, we made sure we close it. Let's see here what we are actually doing. We are creating a list of elves which already contains 10 elves, which is obviously wrong because we don't want any elves in the beginning. So if we look here, we already have 10 in it, but we just want the capacity to be 10 and not the length to be 10. So this is basically something which was wrong in the beginning, so I didn't understand correctly what I was doing. Nice to have this. So again, run through it. Now we have 10 elves less. Makes sense, right? Because we create a new elf in we start with 0. So now the first elf has 40,711. So does this match up? We could try to calculate this. But I guess this would be right. So now let's, but coming back to the question, what actually was our main purpose? It was find the elf carrying the most calories. How many total calories is that elf carrying? Okay, so for that we just need to loop through it and store the elf with the most calories. So therefore how do we call him? With most calories. We can initialize it with the first one because we know we know that it will be at least 1. There will always be at least 1, so therefore we can just store it. So and now we store we can just store the elf directly and not just the number. So we just say oh no, this was fine. And we say this is from type elf. Okay, and now what we do, we basically compare the total calories of each individual elf that when we loop over with the most calories that the current elf has. So basically if elf dot total calories is greater than elf with most calories dot total calories, then we basically say that our elf with most calories now is the current elf. So this means in the end we should end up with elf with most calories with most calories. Okay, let's try to run it. Invalid memory address or nil pointer reference. Sure, makes sense, right? Because we have here this comparison and we don't initialize this variable, which means basically it's a nil pointer. It doesn't point to anything. Therefore, it's safe to basically initialize it to the address of the first elf. Okay, and there it is, but this doesn't look right. Because it's obviously not the one with the most calories. So there is definitely something fishy going on. So if elf total calories bigger than elf with most calories, total calories. Okay, so going back to our debugger. Just run it in the debugger. Okay, we just loop over it. We don't care. Let's go to here. So we know our now elf is basically our first elf. And this is the same one. Yeah, so therefore it shouldn't do anything. So we loop over the next one. Now, total calories. Okay, now let's take a look into this. What is total calories? Okay, and what is elf with most calories, total calories? Okay, so this is definitely larger. Therefore, it's fine to assign it, right? To say, okay, we save the second elf at the one with the most calories. Okay, next one. No, this is not the case. Oh, as we see here, this doesn't look right. Because this is always the same, right? Okay, now we go back to some problems that I think might be with the way how we actually store the elf. So in Go, all these things are basically copied. And I think this might be the problem that we actually have, that we always create a new copy of those elves, and then we create the pointer to a copy that changes. So therefore, instead of storing elves, we should store pointers to elves. This allows us to make sure they are not copied when we loop over them. Elf with most calories, and then we can also call this from the pointers. This is now that, this is now this. Okay, let's try it again. Now elf and elf with most pointers. Okay, this looks good. This looks good. And as we see, the elf with most calories, total calories, doesn't change at all anymore. So it's not copied and changed underneath, which is basically what we would expect. So, and now here we found one with 61,533, 69,000, 72,000. Wow, okay, so in the end we print out elf with the most calories, 72,070. Nice. Okay, so now the question is, how can we actually submit this solution? So, answer. Okay. We copy our submit. That's the right answer. Okay, this means we have our first star for this year, which is actually quite nice. Okay, should we also do part 2? Let me check. Why not? Why not? We still have some time left. Okay, continue to part 2. By the time you calculate the answer to the elf's question, they've already realized that the elf carrying the most calories of food might eventually run out of snacks. Okay, which is a pity. To avoid this unacceptable situation, the elves would instead like to know the total calories carried by the top 3 elves carrying the most calories. That way, even if one of those elves runs out of snacks, they still have 2 backups. In the example above, the top 3 elves are the 4th elves and the 3rd. The sum of the calories. Find the top 3 elves carrying the most calories. How many calories are those elves carrying in total? Okay, so a slight modification. Instead of only storing 1, we need to store all 3. So let's basically copy that. Oh. And add at the end top 3 elves. And here we have we have a slice or an array of 3 of elf. This is not the correct way. I always get it wrong. Var. Yeah, this is okay. So we store our top 3 elves. So, but the principle is basically the same. We loop over every elf that we find. Then basically we get the total calories that they have. Total calories. And then we compare those with the top 3 that we have. So if top 3 elves, but now we need to check if we actually have already some top 3. So we only check this if this is null. No, we check if it's nil. Basically, we know we don't have the top 3 or this position in the top 3. Therefore, we need to make sure we set it. So if it's equal, or if the top 3 elves their total calories is smaller than current total calories. So if this is the case, basically what we do is just we copy everything below. So we copy top 3 elves. So we push on top, let's say it that way. And therefore we need to adapt what comes afterwards. So we say top 3 elves 2 is equal top 3 elves 1, top 3 elves 1 is equal top 3 elves 0 and top 3 elves 0 is our current elf. We don't need the index, I think. Okay, so this for the case when it's the first one. So now we need to check what happens if it's about the second one, which basically works in the same way. Else, if 1 is null, or 1 total calories is smaller than the calories of the current elf, but then we only need to push down 1, so the top doesn't change. And in the same way, we do this basically for the third position. So if the third position is nil, or the third position calories are smaller than the calories of the current elf, then we basically overwrite it with the new elf. So, and then we go over it. And say top 3 calories is equal top 3 elves 0 dot total calories plus top 3 elves 1 total calories plus top 3 elves total calories. And now have a small top 3 elves are carrying okay. And that should be it. Let's run it. 211,805 calories. This sounds about right. When we see that the topmost elf has 72,000, so triple that should be about it. That's the right answer. Yes, okay. That's it for today. So we are done with that. So feel free to ask questions, reach out. Was a pleasure, and see you then tomorrow for part 2. Bye everyone.